Welcome back to the review. We are going to start at number 12. Let's jump right in. The diagonals of rectangle WXYZ intersect at V. WXYZ go around my figure, not across my figure. Intersect at V. WV equals 3x plus 32. That is a half diagonal. ZV equals 4x plus 6. ZV, that is also a half diagonal. In a rectangle, since my figures are a rectangle, I know my diagonals are bisected and congruent, so these two pieces will be equal to each other. So my 4x plus 6 is going to be equal to my 3x plus 32. First thing I'm going to do is subtract 3x on both sides. That's going to leave me with 1x plus 6 equals 0 plus 32. Subtract 6 on both sides. And x equals 26. Did I find, it says find the value of x? Yes, I did. X equals 26. It said write an equation to find x. That's this here. Then find x. That is this here. Okay. Let's look at number 13. In rhombus WXYZ, the diagonals intersect at V. Let's draw that. It's a rhombus this time. So that means all of my sides are the same. WXYZ go around the figure, not across the figure. Diagonals intersect at V. ZX is 24. This whole thing here, I'm going to rewrite that out here, is 24. WX is 15. What is the area of the rhombus? Area of a rhombus is 1/2 its diagonal 1 times diagonal 2. So area of my rhombus is 1/2 diagonal 1 is 24. Diagonal 2 I don't have any information on, but I can find out how big this little piece here is because I have a 90-degree angle in a rhombus. And all my diagonals are bisected, so if this is 24, this little piece here is 12. And so I need to find this leg. And to find a leg, we subtract 15 and 12. 15 is bigger, so it goes in first. Don't forget to square them. The square root of 15 squared minus 12 squared. Square root of 15 squared minus 12 squared is 9. Nice whole number. I like it when that happens. So if this piece is 9, this piece is 9, and that whole diagonal is 18. So my area equals 1/2 of 24 times 18, or half of 24 is 12. 12 times 18 is 216. I don't have any units, and I know it's area, so it's going to be squared, so I'm going to write units squared. There is my area of that rhombus that I had to draw my own picture for. Alright, the next one, find the area of the composite figure. And what's kind of nice is they already drew dotted lines in there for me. So I can do an area of a triangle, an area of a rectangle, and an area of a rectangle. So for my triangle, area is 1/2 its base times its height. The base is 1, 2, 3, 4, 5, 6, 7, 8. The height is 1, 2. So 1/2 of 8 is 4. 4 times 2 is 8. So this is 8. My rectangle here, I already counted this across the bottom here was 8. So for my rectangle, it's just base times height. I already know I have 8 for my base. My height is 1, 2, 3, 4. 8 times 4 is 32. And then this little one down here, my area is base times height because it's a rectangle. So it's going to be my base is 1, 2, 3. My height is 1, 2. 3 times 2 is 6. So my total area is going to be, I put my 6 over here, 8 plus 32 plus 6, which is 46 square units. Okay. On my next one, number 15, find the area of the figure. There's a few different ways you could try to divide this up. I could put a line here and say I have a little horizontal rectangle, and then I could put a line here and have a really long rectangle and then have a triangle. Okay. I could put a line here and have a tall rectangle, and then put one here and have a rectangle here and a triangle here. But here's kind of what I think I'm going to do, because I want to try to do this in as few steps as possible. I'm going to draw a line here. And the reason I'm going to draw a line there is because, well, then that makes this one a rectangle that's 5 by 10. So that side is 50. And then because I have my 90 here, and when I draw this in, I end up with 90 here, right? So this, believe it or not, I can prove that this piece here is parallel to this piece here, and this is perpendicular, this is not. This, my friends, is a trapezoid. So I only have to do one more formula. I'm going to use my trapezoid, 1/2 my bases added together times the height. My two bases, now it looks like it's 15, but it's not, right? All the way across is 15, and I've used 5 right here. Okay, so from here to just here is not 15, it's only 10. So one base is 10, the other base is 7, and then this height here, where my 90-degree angle is, this height, the whole height is 10. I've used 6 here, so this has to be 4. My area here is 1/2 of 17 times 4. I believe that's 34, because that's 2 times 17. 1/2 of 17 is 8.5 times 4 is 34. I was correct. So then my total area is going to be the 50 plus the 34, which is going to be 84. And my units here are inches squared, square inches. Okay? All right, and the last problem in this section, write an equation that would allow you to find the value of x so that this quadrilateral is a parallelogram, then find x. So if I want this quadrilateral to be a parallelogram, I know that these two opposite angles are going to have to be congruent. They have to equal each other. So my 4x minus 8 has to equal 3x minus 2. So it says write an equation that would allow you to find x. Done. Then find x. Okay, let's find x. Subtract 3x on both sides. 4x minus 3x is just 1x minus 8 equals 0 minus 2. Add 8 on both sides. Don't forget that that's a negative 2. Negative 2 plus 8 is 6. So x equals 6. If you want to check that answer, you can plug it back in. 4 times 6 is 24. 24 minus 8 is 16. 3 times 6 is 18. 18 minus 2 is 16. So both of these angles, even though they don't look like they're 16 degrees, both of these angles are 16 degrees. Okay? All right, so that is 12 through 16. When you come back, we will continue with some reviewing, some quick just talking about some properties of different shapes that we have. All right, so thanks for watching. See you in the next video.